So in this video, I'm going to talk about the Vant Hoff factor. All right. If you remember from the lab that we did, the Vant Hoff factor is actually determined by the number of things, and here I'm going to use the number of things, all right, produced when a solute dissolves. And so in the lab, we talked about how sucrose has a Vant Hoff factor of 1. And the reason it has a Vant Hoff factor of 1 is in solution, it looks just like sucrose. It looks like molecules of sucrose. They don't break apart into constituent pieces, right? It stays as a molecule. So the reason I use the term things is because sucrose forms molecules, whereas something like sodium chloride showed a Vant Hoff factor of 2, and the reason it does is because in solution it forms sodium ions and chloride ions, right? And furthermore, calcium chloride had an I of 3, a Vant Hoff factor of 3, because it forms 3 ions, the calcium ion, the chlorine ion, and another chloride ion, right? So it is important for us to be able to do these colligative properties problems, these freezing point depressions or boiling point elevations. We need to be able to look at something and tell whether or not it is what its Vant Hoff factor is going to be, whether it's going to dissociate into multiple things or just all stay together as one thing. So that's what we're going to show right here, right now, is how to determine the Van Hoff factor. Vant Hoff factor. And a quick reminder, right, is that the Vant Hoff factor is I. And the reason it's I is because it is most relevant when we have an ionic compound. That's what we're going to talk about today. Believe it or not, the best thing you can do first is check and see if it's a covalent compound versus an ionic compound. And as a quick reminder, you may ask yourself, you say, it's been like 6 weeks since we talked about ionic and covalent compounds. I know it's been a while, but it is really important here, right? And this is the whole reason we studied this back then, was to be able to tell this difference here. So covalent compounds, the I is always going to be 1. They will not dissociate in solution. They will not form anything other than the original molecule. They will stay all as one package deal. And if you remember something like sucrose, actually I think that's C11, oops. Any compound really with this organization structure here, right? Carbon, hydrogen, and oxygen, remember these are all nonmetals. And any compound that is all nonmetals is a covalent compound. Now that may bring up a lot of things that you want to remember here for the end of the semester, or maybe you don't want to remember, but covalent compounds, remember, share electrons between their atoms, right? They don't have ions, right? There are no charges here. These are all neutrally charged atoms that are sharing electrons between them. But they are all nonmetals. And how do I know if they're nonmetals? Well, remember, the nonmetals, if I look at the periodic table, let me draw a quick and fast and dirty periodic table over here. If I look at the periodic table, remember there's that stair-step line. The nonmetals were the ones to the right of the table. And the metals were everything over on the left, especially those group 1 and group 2, but really anything on the left-hand side of the periodic table, including those just to the left of that stair-step line. Good reminder, good quick reminder there. Because the next thing we're going to look at is an ionic compound. In an ionic compound, I is the number of ions. So if you see something like NaCl, this is a metal, and this is a nonmetal. So quick reminder, metals form positive ions. This one happens to be in group 1, so it forms a +1. Nonmetals form negative ions, Cl -1. And you have to do the group number -18. So since chlorine is in group 17, you take away 18, you get -1. And that's why these two dissociate. They form ionic compounds. So we'd check the number of ions, 1, 2. That gives us an I of 2 for sodium chloride. So it's worthwhile practicing a few of these. I'm going to throw a few at you. As soon as I write down the formula, you should pause it and see if you can identify the I of that. And then unpause it, and I'll tell you the answer, and I'll tell you why that answer is the answer. All right? So we'll start off with a relatively few simple ones. SO2. Hit pause. This compound is covalent. Both sulfur and oxygen are on the right-hand side of the periodic table. They're both to the right, both in group 16, actually. And so since it's covalent, I equals 1. What about barium bromide, which looks like this? What about that one? Pause. This is ionic. And if you look, it's got all ionic compounds divide in half. There's a positive side and a negative side. On the positive side, we have one thing. On the negative side, we have two things. 1, 2. So how many check marks? 1, 2, 3. The I on this one is 3. How did I know this was ionic, by the way? Just a quick reminder, right? Barium's way over on the left-hand side. It's in group 2. Bromine's on the right-hand side. So that one had I equals 3. I'm going to stop writing covalent and ionic and just go straight to the I's from this point onward. I'm going to throw a little noodle at you, a little head scratcher. What about sodium nitrate? Sodium nitrate. Pause. Now to look at this one, another ionic compound. Right, sodium's way over on the left. NO3, nitrogen and oxygen, I should say, are over on the right-hand side. This is ionic. So where do I divide this up? Well, the division goes right there. This is one of those polyatomic ions. If it's got a polyatomic ion, it has to be ionic, right? So that polyatomic ion, believe it or not, it does not count as 3. It only counts as 1. All that together counts as 1. And sodium counts as 1 as well. So believe it or not, this one has an I of 2. Somebody immediately says, hey, what about a polyatomic ion where there's more than one polyatomic ion? How do I know when I have more? If that only had 1, how do I know when there's more than 1? Let's see. How about strontium chlorate? Pause. All right, it is definitely ionic because I see a polyatomic ion here, right? Got to be a polyatomic ion. I remember those things being in parentheses, subscript outside of it. We're going to divide this one up again. There's only one positive ion, but there are 2 of those chlorates. 2 of those chlorates means that the I for this thing is 3. Let's turn it up a notch, just a little bit. Let's write down this one right here. What do you think the I value of that one is? If you said I equals 3, you are correct. Notice the positive ion here is the polyatomic ion. That thing is called ammonium, and there are 2 of them. That 2 right there. How many oxygens are there here? Well, it's understood to be a 1 there. So there's 1 there. 2 plus 3 gives me an I of 3. I got a couple of more of these that I can throw at you. Just a couple more. A great one would be something like this. Ammonium phosphate is what this thing is called. See if you can figure out the I. Sorry, you were supposed to pause it back there. If you haven't paused it yet, pause it now. Try and figure it out. Now we're good. All right. So how many ions do we have here? Well, we divide this in half. The ammonium and the phosphate are two different halves here. There's a positive half on the left, negative half on the right. There are 3 of these. And if you wrote that there are 4 of these, you got it wrong because there are not 4 there. Remember, right, that's all a polyatomic ion. What's outside that thing is a 1. This one has an I of 4. That's about as difficult a one as I can make. I can think of something slightly more difficult where I ask you, what about like carbon dioxide? Pause. And then you come back and you say, wait, you're not fooling me on that one. That's I equals 1. That right there, you forgot to check. Is that one a covalent compound? You better believe it. You better believe it. Covalent compound, so I equals 1 on that one. What about something like NH3? Pause. Some of you probably didn't even pause it because as soon as you wrote it down, you said, no, I got it. It's I equals 1. That's also a covalent compound. Something weird happens when you put that one in solution, though. We're going to talk about that next week. Last one, most difficult one. What is the I for this one? Al2SO4 3. Aluminum sulfate. Pause. Resume. Draw that dotted line down through there. We have 2 aluminums and we have 3 sulfates. This one has an I of 5. Great. The next video will show you how we're going to use these numbers to do math.